Section 1.5, we're analyzing graphs of functions. We actually did this a little bit in the last notes, so this first part hopefully will be pretty easy. So the easiest way to determine whether a graph is a function or not is to apply this thing called the vertical line test. We actually talked about it in one of the examples from 1.4 notes. We're asked to state whether each graph is a function or not, and then state the domain and range of each graph using correct notation. So for the first one, it fails the vertical line test miserably. Like, it fails everywhere you draw a vertical line. So it's not a function. Now, after that, we're asked to come up with the domain and range. So the domain, again, just a refresher on this. We're using that squiggly bracket. We got first of all, our variable for our domain, x, is an element of the real numbers. And in this case, we're not going to be able to use every x. You'll notice the furthest we go to the left is 0 here. So we never go to the left of 0, but it's 0 and then everywhere to the right of it. So we're going to say x is an element of the reals. That means that's the type of number we're using. We're using real numbers. But we're going to have to say x is greater than or equal to 0. Every real number you can think of as long as it's greater than or equal to 0. So essentially just no non-negative numbers. For the range, looking at this graph, again, starting off with the same format, y is an element of the reals. Looking at this graph, it's going to go forever up and to the right and also down and to the right. It's going to go forever negative, forever positive, and it's going to hit everything in between. So we're actually done with that statement. We're just going to say y is an element of the reals. Now let's pause and try the second one. And you clearly pause and try the second one. Is this a function? Sure. Yeah. If you draw vertical lines anywhere you want, it's going to pass, pass, pass. So it is, in fact, a function. The domain, x is an element of the reals. That part should be kind of familiar by now. And then looking at this, it's going to go forever to your right. That's your right, sorry. Forever to the right and forever to the left, and it's going to hit everything in between. So it's going to go x is just an element of the reals. The y values, the range, I should say, describing the y values, those are also going to be real numbers. You'll notice over here it's going to go forever up, over here it's going to go forever down, and everything in between. So we're just going to say y is an element of the reals. Last one here, domain, or sorry, is it a function? Yeah, sure. It's weird, but there's no there's nothing saying it can't be a function. If you were to draw vertical lines here, it'd pass, it'd pass, it'd pass. Let me zoom in so I'm not quite covering it. Actually, let me just move my image over. Okay, there we go. Sorry, editing on the fly. So the domain on this one, oops, sorry, that's shape mode still. So the domain, still talking about x's that are real numbers, but it's not going to be every x value. In fact, there's a big gap that it doesn't equal. So for example, it doesn't, there's nothing in this area here. Nothing between 0 and 2. So what we're going to say is x is an element of the reals such that x is, for the one on the left, sorry, I'm writing it weird. For the one on the left, it's going to be to the left of 0. So we're going to say x is less than or equal to 0. And then for the other one, we're going to say x is greater than or equal to 2. So just anything not between 0 and 2. For the range, talking about them y values again. So y is an element of the reals, such that the lowest value we see of y is 1 over here and over here. And it's going to go up forever in both. So we're going to say y has to be greater than or equal to 1.